Hey everyone, so we have another MATHCOUNTS questions. So this was a target chapter level, so number 8, okay? So we have a person, which is Kate, arrives at the office and she says either good morning or just skip that for some days. On Monday, she says good morning, okay? On each next day, subsequent day, there's a 75% chance that she will repeat that behavior. So which means since she said good morning on Monday, so she's gonna probably 75% will say good morning again, but there's a 25% chance that she's not. Okay, so that behavior will continue on each day. So based on the previous day, so next day might be different, okay? And the question is asking, what is the probability that she's gonna actually say good morning on Friday? So this is actually really nice, a recurrence relation problem, which is something it was something we can like easily see based on the previous day, we are gonna get next day. So if you have some relation like that is related to the previous day, that is called recurrence relation. So this is one of them, okay? So, but we don't really know how this is gonna look like without really having the previous day. So previous day is not really obvious either. So which is why I'm gonna make a statement. So let's say so she's gonna say good morning. Okay, let's say she's gonna say good morning. On I say day X. So let's say probably of saying like she's gonna say good morning is, let's say, P of X. Probably of saying that will be P of X. Okay, that means she's not gonna say good morning on that day X. It will be 1 minus X. So no good morning, I would say. Okay. On any day, which is on day X, is gonna be 1 minus P of X, okay? X is the day. Let's say Monday is 1, like Tuesday is 2, like Thursday is just continue that way, okay? And Friday is gonna be 5. So we know we start with Monday, which is she already said good morning, which means if I say P of 1, that's already obvious, which is 1, because that is like already known. So 100% she said already 1. So, but before we doing the P of 2, so let me make it with maybe general statement. So I'm gonna say, if this is the problem of getting a good morning, saying good morning on like day X, okay? So the next day, which is P of X plus 1. So like if you replace X with 1, so that would be P of 2, which means the probability of like her saying good morning will be on Tuesday, okay, the mean of that. So this is gonna be equal to, she has a 3/4 chance, 75%, okay, that she will say good morning, which is the like problem of saying good morning was P of X. So I should multiply this by P of X. Okay, and now we have 1/4 chance that she's not gonna say, okay, so that would be 1 minus P of X. So this is probably the most important step of this problem. So you really need to understand this equation before you move on. So again, I said the probability of the saying like her saying like good morning is P of X on any day. So let's say day 1, day 2, let's say P of 1, P of 2, like I just made a general P of X. And then if that's the probability I was saying like good morning is P of X, then 1 minus P of X should be she's not going to say it, okay? And then since we have a recursion, because the next day will always depends on the previous day, so P of X plus 1, which means the probability of her saying good morning on the next day, which is X plus 1, is going to be 3/4 times probability of her saying in the previous day good morning plus 1/4 times probability of her saying nothing, okay? So that is the two things that could happen. So we just need to add them. So let's simplify this a bit. Okay, so that will be 3/4 P of X. And then we have 1/4 times 1, which is 1/4. And then this times minus P of X, so which is P of X over 4. So 3/4 minus 1/4, just 2/4, which is 1/2. So 1/2 times P of X plus 1/4. So that was equal to P of X plus 1. Again, this is what we are going to use, okay? So it says the probability of getting a like good morning from her is next day is going to be 1/2 times the previous day's like probability of getting a good morning plus 1/4. So now let's look at the numbers. So we start with day one. Day one was like Monday, which was 1. If you replace X with 1, so that would be P of 2. Okay, so that would be P of 2 equals 1/2 times P of 1, which is 1, plus 1/4. And that's 2/4, that's 1/4, so that will be 3/4. So that is P of 2, which is Tuesday. So let me write this guy. That's Tuesday. And if you do the next one, so if you place now X is 3 in this equation, if you replace X is 2 actually, if you replace X with 2, that will be P of 3. And that will be P of 2, which is 3/4. So that will be 1/2 times, 1/2 times P of 2, which is 3/4, and plus 1/4. So that's 3/8. So I can multiply this by 2, which is 2/8. So that would be 5/8. So the P of 3 is my Wednesday. So she's gonna probably say good morning on Wednesday, 5 out of 8 like chances. Okay, so that's Wednesday. So let me continue with the next one. So if I now plug X like 3, so this guy will be 4. So 1/2 times P of 3, which is 5 out of 8, plus 1/4. So this is 16. So I may multiply this by 4. So 4 over 16 plus that will be 9 over 16. Okay, so I have this guy as my next day, which is my like Thursday, right? Okay, let me write that as well. Okay, so last day is Friday, which is what we are trying to find. So the next day, maybe I should write here. So P of 5, which is a Friday. So I will just replace X with 4, right? So that will be P of 5. That will be 1/2 times P of 4, which is 9/16, plus 1/4. So this is 32 as denominator, so that would be multiplied by 8. So 8 plus this will be 17 over 32, which is we cannot really simplify anymore. So that would be my answer. So here's my challenge for you. Based on this one, we got some actually really nice relation. So can you make actually a formula for any day? Like in this case, we were looking for the 5th day, which was not too challenging to find it. But I think if you really use this equation a bit like carefully, you may find a really nice formula. Maybe I will give you a hint to try, maybe a sequence or series, or maybe you can just challenge yourself to find a formula for the nth day. So if I ask you what's the probability of her saying maybe in, I don't know, 25th day, or I don't know, like 256 days, whatever. So if I ask something like that, so just finding each day like from the previous day will not be really fun. But in this case, it was okay. So can you challenge yourself to find that formula? Okay, so this was a really nice, actually, recurrence relation problem. So I hope that was clear, and I'll see you next time.